Okay, today we're going to take a look at finding limits graphically. My favorite topic in terms of limits. So the learning goal. Students will be able to solve limits graphically. Very small learning goal. We're going to use what we learned in the other two videos to do this. Remember, I'm trying to drill this in you, that all a limit is it's the intended height of the function. Even though we might never ever reach it, we'll get awfully close. And we are doing graphical approach in this video, my personal favorite. So let's go ahead and let's revisit what a left hand and a right hand limit looks like. Okay, so for this video you're going to definitely need what a right-handed limit looks like. And all a right-handed limit looks like is this. Limit as x approaches 2, and we say from the right because of that little plus of f of x. In terms of the left-hand side, limit as x approaches 2 from the left of f of x. We know that it's left because of the little minus. We know that it's the right-hand side because of the little plus. Now the most important part, if you want to show that the general limit exists, and the general limit is just right down here, limit as f of x approaches, limit as x approaches 2 of f of x, that's just the general limit. There's no plus or minus. Now notice, because on top here I have from the right equaling to 4, a height of 4, and from the left equaling a height of 4, then the general limit must exist. So all you need to do to show there that the general limit exists is show that the left and the right-handed limit both are equal to the same number. Okay, so let's go ahead and start example 1. It says, for the function f, graph below, find all of the following. Now I know you're a little intimidated. I don't want you to be. We're going to take it one step at a time. So let me grab my lucky marker, Mr. Blue. And here it says for part A, limit as x approaches 3 from the left-hand side. You get really good at this just by practicing. If I'm going from the left-hand side, the curve that I see on the left is, and I'll even highlight it for you here, is this part of the curve right here. It's still f of x, it's just that's the left-hand side. So if I grab my blue marker, that means I'm looking for the height as I approach from the left. And it looks like the height is going to be -1. That's how simple and fast you can do this. Part B, if I'm approaching from the right, that means I'm coming in this direction of my highlighter. So I'm coming in from the right, and I don't want you to worry about the hole. Remember that it's the intended height of the function, and I'm approaching 3 on the x-axis. So this is 3, just like before, and it looks like my height of this function would be +3. Now a lot of you out there will say, oh well, wait a minute, how come it's not +1? Well, in the definition of a limit, it says the intended height of the function. Limits don't care about order pairs, points. They just care about the actual function. So it's kind of a distractor for you. But let's push on. Now the general limit, does it exist? Well, because I have the height of -1 from the left and a height of 3 from the right, the general limit, we say, does not exist. Okay, now on D, once again, it's kind of a distractor. It tries to throw you off, or I try to throw you off. There's no limit here in front. So this is just an order pair. This is just f of 3. Now, an order pair to finish off the height is definitely going to be 1. So that's where I'm looking at this point right here. Okay, a little bit more complicated. Limit as x approaches -infinity of f of x. Okay, so if I'm approaching -infinity, I'm going this way. Now, what's the height when I'm approaching -infinity? Well, it looks like I'm using this curve right here that I highlighted in blue, and the height is going to be -1. Never changes here. And then in terms of, let me grab another color, limit as x approaches infinity, positive infinity of f of x. That's this curve, and if I go to positive infinity, my height, it looks like it's going to be 3. So I know that was a lot to take in. We're going to do another example that's similar. These are kind of fun. I enjoy these, so hopefully you will too. Okay, so it says basically the same thing for example 2. For the function f, graph below, find all of these things. Okay, so no worries. Limit as x approaches -2 from the left. Okay, here is -2. And if I'm approaching from the left, I'm going this direction. Now my height's going to be, it looks like, 0. Remember that if there's a hole there, it's okay. We're not looking at the order pair here because limits in the definition basically say the intended height of the function. So we don't really care about this order pair right here. Okay, from the right hand side, so the limit as x approaches -2 from the right, that means I'm going in this direction here. And I'm approaching closer and closer to -2. It looks like my height is 0. Oh, nice. That means because the left and the right are equal to the same height, that the general limit exists, and it's also 0. Perfect. Okay, part D, f of -2. Okay, because there's no limit here, it just means it's an order pair. And we're used to seeing order pairs like this, -2, comma, something. In calculus, we can write it as f of -2 is equal to the height. And the height here, it looks like 1, 2 up. So it's going to be equal to 2. Remember that in Algebra 1 we would write it like this. In calculus we would write it, even in pre-calc, more like this. Okay, something kind of tough for people. Limit as x approaches -infinity. Okay, so basically I'm going to grab blue, and if I'm going this way to -infinity, my height looks like it's continuing on. It looks like it's reaching positive infinity. Remember, I'm looking at a height, so I'm looking at this right here. It looks like it's going all the way up. Limit as x approaches positive infinity. Okay, that means I'm going this way. And once again, your height here looks like it's going higher and higher and higher, so it's positive infinity. Now, there's no next question, but my question to you is limit as x approaches infinity. Okay, we know it's going to be infinity, correct? And these are both general limits here. But if I had a function, which I don't here, if I had a function where I have basically a left-hand side that goes to infinity, and I have a right-hand side, which I don't in this graph, going to infinity, would the general limit exist? That's the question. So remember, there would be a little function here, little function here. I want to have appropriate notation for you. And the answer to this is no, it doesn't exist. And the reason why is, even if I sketch a curve for you here, say I have a curve and it's going from the left to infinity, from the right to infinity. On this curve, I don't know when the left is going to stop. I don't know when the right is going to stop. And we don't know what infinity is. So just because they're both equal to infinity, in this case, doesn't mean that the general limit exists. Now, for this graph, just know that the limit would have to approach 0 for this to be true. So that's what happens when I make a hypothetical graph up. But the idea is there. Anyways, let's go back to our learning goal. Students will be able to solve limits graphically. I do think you'll be able to do this with a little bit more practice. Do brush up. Try the questions on your own. Revisit the video. Like I said, it'll be your favorite topic as well, hopefully. I'll see you on the next video.